Question number 3. Okay, we have an object, a small ball, dropping vertically onto a slope inclined at an angle alpha. It bounces off at an angle of 45 degrees. Okay, we're told the coefficient of restitution is E, and we're just working with that. Now, the way I would always approach these, I'm not saying it's the only way, but I would break this down to 2 components. So that way and that way. And then I'm going to break V down into its 2 components, that way and that way. Clearly not drawn to scale. Now we know that this is alpha, so this is 9. You can work it through, you end up finding this is 90 minus alpha, so this is alpha up there. And you could work it through by just dropping a vertical here. So this is alpha, this is 90 minus alpha, therefore by opposite angles, and therefore that's alpha up there. So the one down the side here is going to be U cos alpha, and the one here is U sin alpha. We know afterwards, after it's impacted, that the horizontal one will be unchanged, so this is also U sin alpha, and therefore we know the one perpendicular to the plane is U cos alpha times E. Okay, so I've not really considered what the question is at all yet. I've just looking at what I know, what I don't know. Okay, so, and one other thing, I haven't used this 45 degrees yet, which clearly must be used. So I know that this and this are equal, because tan 45 equals opposite over adjacent, and I know tan 45 is 1, so that tells me if I move the sine, the u's will cancel, move the sine alpha up, divide by the cos alpha, I end up with E equals tan alpha. Okay, now the question actually asks you about the magnitude of the impulse. So impulse is mv minus mu, okay, change in momentum, which is v, the velocity afterwards. Remember, I'm doing impulse perpendicular to the plane because horizontally doesn't change. So I've got v sine 45, and then I've got u cos alpha. Okay, notice the change in sign here because v is going that way and u is going the other direction, which gives me m v sine 45 is, didn't need to put v sine 45, I could have just put this one, sorry, bear with me. So v sine alpha we know is EU cos alpha plus U cos alpha. Okay, so we know E is tan alpha. Let's take the U out. So MU, E is tan alpha, so we get tan alpha cos alpha plus cos alpha, which is MU sin alpha plus cos alpha. Okay, we now need to get sin alpha and cos alpha in terms of E's effectively. Okay, so let's do a little aside if you like. So sin alpha plus cos alpha. Because I've got tan alpha in terms of E, I'm going to divide everything by cos alpha. So I'll get cos alpha times over cos alpha plus cos alpha over cos alpha. Okay, because that will cancel with those to give us sin alpha plus cos alpha. So that equals cos alpha times tan alpha plus 1. Now got to get the cos alpha in terms of e's. So this is the same as tan alpha plus 1 over sec alpha. Sec alpha is 1 over cos alpha, which is the same as cos alpha at the top, which you can see why this is quite a difficult part. Tan alpha plus 1 sec alpha is the square root of 1 plus tan squared. Okay, so therefore we get, after all this, get e plus 1 over root 1 plus e squared. So finally, that implies the impulse equals mu e plus 1 over root 1 plus e squared. Just thought of a slight alternative. This cos alpha term, because we know tan alpha is e, so tan alpha is e and tan is opposite over adjacent. I know the hypotenuse is root 1 plus e squared by Pythagoras, so I know cos alpha is adjacent over hypotenuse. So instead of doing this tan squared and the sec business, I could have just replaced this cos alpha with that, which would have made life a little bit quicker. And in fact, I could have carried this on. I've got sin alpha is e over root 1 plus e squared, and I could have just plugged these two, sin alpha and cos alpha, straight back up to here. Okay, so several ways of approaching that question.